So in problem 7.3.2, we're asked to calculate the enthalpy of the equation based on the bond strengths that are given in table 7.3.1. So to do this, we have to convert the chemical reactions that were given into Lewis structures. So the double bonded C's, both of them will be attached to H's, plus H2 gives us C2H6, which is all single bonds. And we have to do this so that we can visualize what kind of bonds each of these structures have so that we add up the right values. So we can count our bonds. We've got one C double bond plus 1, 2, 3, 4 CH single bonds plus 1 H single bond. And then over here we have 1 C single bond and 1, 2, 3, 4, 5, 6 CH single bonds. Remember, it's bonds broken minus bonds formed. So it's going to be 1 CC double bond, we can look that up in the table, and that's 611 kilojoules, plus 4 CH single bonds, each of which are 415, plus 1 hydrogen single bond, 436, minus all of the bonds formed. I have 1 carbon-carbon single bond, which is 345 according to the table, plus 6 CH single bonds, again, are 415 each. So when we add up those two sums and then subtract them from each other, we'll find that delta H is equal to negative 128 kilojoules. We do not have to do kilojoules per mole because we multiplied by the coefficients, the molar coefficients from the equation, so we accounted for the moles already. Part B, we do the same thing. This time we have C2H6, which we're drawing again as the Lewis structure, so we can count our bonds, plus 7 O2s. Now you could write out the 7 O2 Lewis structures, but it's faster in this case to just remember that there are 7. However, if you're not going to be able to account for all 7, just draw all 7 so you can count them. We have 4 CO2s. CO2 is double bonded O's to the C, and 6 H2O's. So if I go through and I count all my bonds, again, I have 1 carbon-carbon single bond, 6 carbon-hydrogen bonds, 7 O double bonds, and then over here there are 2 CO double bonds, but I have 4 CO2s total, so I actually have 8 CO double bonds. And the same thing here, I have 2 OH bonds, but I have 6 of them total. So all told, I actually have 12 OH bonds. So if I look at the table, bonds broken minus bonds formed, I can put values on each of these counts. So I have 345 plus 6 times 415 plus 7 times 498. Now, mistaking that OO is a double bond, not a single bond, is a common place where people get messed up on these problems. Then I'm going to subtract the bonds formed. I have 8 CO double bonds. Each of them are 741, plus 12 OH bonds, 464 each. So all told, my delta H is going to be equal to negative 5,175 kilojoules.